Lesson 12, I will recognize and draw lines of symmetry. So the first thing I want to tell you today is that you're not going to need your math journal because you actually have an activity sheet that you're going to be using instead of your math journal. But I want you to think before we get started today about what you know about lines of symmetry. You should have learned about symmetry when you were in third grade, and you should know that a line of symmetry is where you could take an object and fold it in half and both sides would match up perfectly. Let's practice a little bit of that. Go ahead and get out your activity template, and at the top of it you're going to see all these different shapes. And the first thing I want you to do is I just want you to take a look at that A, and I want you to think to yourself, okay, if I could cut out that A, which you could, but I don't think you'll need to, but if you cut out that A and you were going to fold it in half, is there a place where you could fold that A in half so that both sides would match up perfectly? Well, hopefully you said right here. If you cut out this A and you fold it in half, this side would match up perfectly with this side. I want you to go ahead and finish this row. As a matter of fact, just go ahead and take a look at every shape on this activity template and think about where could you draw a line of symmetry, and can you draw a line of symmetry? There may be some that do not have a line of symmetry. And then I want you to come back and we will go over it together. Okay, so what about the smiley face? It only has one line of symmetry, right? It's right straight down the middle. And we call this kind of line vertical. When it's up and down, it's vertical. What about the heart? It has a vertical line of symmetry too. What about the H? It has a vertical line of symmetry, but did you notice it also has a horizontal line of symmetry? You could fold it this way too. All right, the star is a little bit tricky. You may not have noticed, but if you took this star, you probably noticed this one pretty quickly. But what happens if you take your paper, okay? Now, I can't take my computer screen, but I can take this image and I can rotate it. I want you to see what happens. Now, my lines are going to kind of stay where they are, but I want you to look at what happens to this star. And I'm actually just going to erase these lines real quick. And I want to show you something. If you took this star and you rotated it, and you can do the same thing with your paper, and you may have already noticed this, but if you take your paper and you turn it, what do you notice about the star? It looks the same when you turn it that way, and if you turn it around this way, it looks the same that way, and if you keep turning it, it looks the same this way, and it looks the same this way. You can do your paper a whole lot easier than I could do this, but what you'll notice is that this star is exactly the same no matter how you turn it. So what that means is, not only does it have a vertical line of symmetry, it also has lines of symmetry from every point to the opposite side. Because this is a 5-sided star, it has 5 lines of symmetry. Okay, what about the hand? Did you see any lines of symmetry on the hand? Me either. It almost looks like it has one horizontally, but if you look, there's 2 fingers on this side, and even though there's 2 fingers on this side, there's not a thumb on this side and a pinky on this side. All right, so the butterfly was kind of easy, just right straight up the middle. The lobster had a nice horizontal line of symmetry. What about this? If this arrow wasn't on this end, you probably could have done a line of symmetry going diagonal, but because this has an arrow on this end and this doesn't, it does not have a line of symmetry. What about the car? You may have thought that it had a vertical line of symmetry, but if you notice, the back of this car is not exactly like the front of this car. It's similar, but they are not exactly. So this one does not have a line of symmetry. All right, let's take a look at the figures on the bottom. And I know this looks a little bit blurry, but basically what you're going to do is you're going to complete the other half. And this has to be exact. That's why they give you this graph paper. So if you have 1, 2, 3, 4 lines on that side, when you complete it on this side, you're going to say 1, 2, 3, 4 lines on this side. And then the same thing here. It's going to go down the same number of lines. 1, 2, 3, 4. And then you can see from up here that they are connected. Then you just connect it using your lines as much as possible to make it as straight as you can. All right, so try this one by yourself and then come back and we'll talk about how I did it. All right, so I'm going to start with the same strategy. I'm going to go 2 over at the top, and then down here it goes 1, 2, 3, 4 at the bottom. So I'm going to go over 4 at the bottom, 2, 3, 4, and then I'm just going to connect these 2 vertices. Okay, so now you have a symmetrical figure. All right, so let's practice a little bit more using our problem set. So it says, circle the figures that have a correct line of symmetry drawn. So take a look at those, and why don't you just try to go ahead and do these first 4 problems by yourself. Circle any of them that you feel like have a correct line of symmetry, and then come back. If you got it wrong, that's okay, just erase it and fix it. Okay? All right, well, A has a line of symmetry. And B almost doesn't look like it does, but if you turned it upside down, you would see that this actually does have a line of symmetry. It's not perfect. Well, actually, I think it is kind of, it is a little crooked, but I think it's meant to be straight. Right? This one does not have a line of symmetry, and this does have a line of symmetry. Now, number 2 says, find and draw all lines of symmetry for the following figures. Write the number of lines of symmetry that you found in the blank underneath the shape. So why don't you go ahead and just try to draw all the line of symmetry and then come back and check with me. Again, if you get it wrong, it's okay. You can just erase it and fix it. All right, so for this is a trapezoid. And a trapezoid only has one line of symmetry. It has a vertical line of symmetry, so we'll say it has 1. This is a square. So this square has symmetry from corner to corner, but it also has symmetry going right straight through the middle like this way too. So a square actually has 4 lines of symmetry. Now this figure, because it has this slant on this side and it doesn't match it on this side, it actually has 0 lines of symmetry. All right, let's take a look at the rest of these. So go ahead and do the exact same thing with D through I, drawing all the lines of symmetry, and then come back and we'll check. All right, so let's take a look at D. Okay, this is a 6-sided figure. Do you know what a 6-sided figure is called? It's called a hexagon, and actually it looks like the yellow pattern block, if you remember from pattern blocks. So we can go from diagonal to diagonal. No, these aren't perfect. But it actually has some more, and I'm actually going to use my straight line here so that they look a little bit better here. Okay, so we're going to use the straight line here, and you can actually go down the middle, kind of like the square, how you can go diagonal, but you can also go through the center. And if you counted these, all the lines that you drew, you don't want to count the same line twice, but you could say, all right, this is 1, 2, 3, 4, 5, 6. And then from here that you've already counted all these lines. So it has 6 lines of symmetry. All right, this little figure that either looks like a pizza or Pac-Man has 1 line of symmetry. And this sometimes tricks kids, but if you'll notice, this is not a line of symmetry. You may have thought that it was, but if you look, this side does not match up perfectly with this side. So it actually has 0 lines of symmetry. And then this raindrop has 1 line of symmetry. And then this figure, it's 1, 2, 3, 4, 5, 6. This is a hexagon too. It only has 1 line of symmetry. And then when you look at this X or square, or not square, this X or this plus sign, it has several. So I'm going to use a straight line here. Okay, so you can go through the corners like this. So you have 2, and then you can go 3, 4. All right, so it has 4 lines of symmetry. All right, now we're going to do this where we complete the other half like we did in our activity set. So again, you can go ahead and try to do this by yourself. All you have to do is count the squares and then come back and you can do it with me. If you get stuck, you can always press play. All right, so I'm just going to use my pen this time. All right, so I'm going to go, it goes 3 that way. So I'm going to go 3 this way. Oops. And then I'm going to go straight down. And I'm going to come back and meet it. So this one's kind of easy. All right, so this one I'm going to go 4. So you go 1, 2, 3, 4. And just be sure to use the graph paper to help guide you. And then you go 3 over, 1, 2, 3. 1, 2, 3. And then I'm going to go back towards a line of symmetry. I'm going to go 2 spaces back towards a line of symmetry. And then you go over 3. And you go away from the line of symmetry 1. And you go over. And then you match it up. All right, let's try these last 2. So this one you can see it goes across 1, 2, 3. So it goes over 3 from this point right here. So if I go over 3, then I have to connect this to this, and then I can come right straight down here. Looks like a kite, doesn't it? All right, same thing with this one. It's going over 3 right here, and then it's connecting. And then here it's going over 3 and connecting, and then connect this. So as you can see, mine's not perfect, and yours probably won't be perfect either. All right, I want you to take a look at the very last problem here, and I want you to think about it. The figure below is a circle. How many lines of symmetry does the figure have? So think about the circle. If you cut out that circle and you folded it in half, where would the line of symmetry be? Think about that for a minute. Well, if I went to try to draw the lines of symmetry, okay, well, this is a line of symmetry, and 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 this is a line of symmetry. What would happen? Could you ever draw all of the lines of symmetry? As long as you went through the middle of the circle, it would be a line of symmetry. You could never count all the lines of symmetry. So do you know what that word is that you call something that you can never count all of them? You call, in math, you use the word infinite. So how many lines of symmetry does this figure have? A circle has an infinite number of lines of symmetry, and it says to explain, so I'm going to say because every line that goes through the center of the circle is a line of symmetry. All right, so I hope that this helps you with symmetry. If you ever get stuck and you're not sure whether or not something has a line of symmetry, you can always cut out that figure and attempt to fold it. That's a good way to see whether or not it has a line of symmetry.